Okay, this is the next question on linear functions and linear programming, and you've got to get the lines in here. And you've got to get the shading correct so you can find your feasible region. So if you're having issue, you've got to do this a step at a time. So C plus S, and just think about it as, well, it's greater than or equal to 8. And, I mean, you can do this in various ways. You can rearrange it, but why not just make, these are like your x's and y's. If you're not happy with c's and s's, turn it into x plus y is greater than or equal to 8. And then do your x and y intercepts. So you can make x 0, and then you can find y, and y is 8. So y is 8. Whoops, y is 8. And then you can do the same thing, make y 0, and what's x? Well, x is 8. So you've got that line there, okay? So you've got your line for the first one in. And the thing is that, well, where do I shade it? Well, it's greater than or equal to 8. So normally you would shade above. So what we ended up doing is always shading away. So if we shade away, we're shading here. All right? And then we do the next one, which is going to be a little bit more interesting, shall we say. Okay, so let's just get rid of all that. And I'm just going to shade that lightly on that side, just so we know where it is. Now the next one, you're going to have to, again, you can do some, put this thing into your equation, your calculator, 900 x plus 600 y is less than or equal to 9900. Now, rearrange that if you want and put it into your calculator if you're going to have trouble finding points. The thing is that if I make x 0, then I have 60y is less than or equal to 9900. And you end up getting, I believe it's y is, and you can just say equals at this point, 16.5. Well, that's not a huge deal because I can find that. That's not a huge deal. And then you're going to do the same, make y 0, so you're going to get 900 x is equal to 9900, and you end up doing the work, and x is 11. So there it is. So it's not a huge deal. You can do that with just making x 0 and y 0, finding your x and y intercepts, and graphing the graph. Now, if you're having issue, it's less than. So normally, if it's less than, we'll shade down below. But in this case, we shade away. So we shade away. Yeah, shade away. Okay, so shading away gets us there. And now we've got to do the other one. Now, the other one we had to change. If you came to class on time, you'd know that we had to change that to greater than or equal to 3s. And so let's just get rid of all that. And what we end up having is x, whoops, x is greater than or equal to 3y. Now, that's not a great equation in that form, but you can get a point. You know that you've got no y-intercept, and if you have to rearrange this, then rearrange it. So you get y less than or equal to x over 3, or 1/3 x. It doesn't matter. And now normally, if that's what you're going to do, now where have we shaded? We've shaded here, and we've shaded here. Okay, so if it's less than, normally we would shade below. And by the way, with an equation like this, right, there's no y-intercept, so the y-intercept's at 0, and then just find another point. And so 2 and 6 is a good point. We could use that, and then draw the line. And now, normally we shade below if it's less than, but we're going to shade above. So there's our feasible region. It's this. Now we're going to have to find the points of intersection of this feasible region. So we've got a point here, we've got a point here, and I mean technically we have a point there and there because we always use X is greater than and equal to 0, Y is greater than and equal to 0. We always assume those because in the context of what we're dealing with, they can't be anything else. So those are boundary lines. Now, what makes this a pretty easy question at this point, once you've got this done, is that the points of intersection are easily obtained from the actual graph, but you can double check it. But 9 and 3 is a point, 6 and 2 is a point, 8 and 0 is a point, 11 and 0 is a point. And you need to show those. You need to write them down, you need to show them. Now we have the objective function to find the profit, the maximum profit, to how many salespeople and how many consultants should employ to maximize their sales. So again, you've got your 9 and your 2. You've got your 9 and 3, 6 and 2, 8 and 0, and 11 and 0. And you simply stick those in to that and find your maximum profits for all 4 of those, and decide and make a decision about who gives you the maximum, which combination, and say it and write it down. And there it is. There's the answer. You work it out, you show your work, you show the results of putting the points in, and you get a maximum solution. So you get your 9 consultants and your 3 salespeople give you the maximum profit. And that's the answer to the question. And that is an A.